Assalamualaikum. My name is Amni Mahira binti Muhammad Hashim.
My name is Hamiza binti Zainir.
So hi, my name is Az-Zahrah Jamal.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sadatul Syuhada binti Muhammad Nazim.
Hi, my name is Farahani binti Muhammad Zulkifli.
Okay, let's start with the introductions. The constant heat permeability test is a laboratory experiment conducted to determine the permeability of the soil. The soil that's suitable for these experiments are sands and gravels. The soils with silt content cannot be tested using this method or these experiments. The constant heat permeability test also can be employed to test the granular soils, either reconstructed or disturbed. The theory of formula permeability, which is K is equal to Q over AI. Q is the rate of flow, A is the area of the sample, and I is the hydraulic gradients.
For objective of constant heat, the first one is permeability test is a viable and economical alternative to measure the permeability of the material. The second one is the experimental results show a direct relationship between the porosity and the permeability as expected. And the last one is constant heat permeability test is to determine the coefficient of permeability of soil. Coefficient of permeability helps in solving issues related to yield of water-bearing strata. Second one is stability of earth and dams. Third one is embankment of canal bank. Fourth one is seepage in the earthen dams. And the last one is settlement issue.
So, how is soil permeability is measured? The first thing we have to know is what is constant heat test. This test is referred to an apparatus where the same relative elevation of the top of water column head pressure remains over the samples throughout the test. It is a valid test for soils with a high flow rate like sands and gravels, and sometimes with some clay soil.
So, what is coefficient of permeability? This is referred to the velocity of water through the soils. Basically, the unit is in meter or centimeter per second. For instance, a fine-grained soil such as clay have a value around 10 to 8 meter per second or lower than that. And another soils such as sand and gravel have values around 10 to 4 centimeter per second and or higher than that.
Soil permeability can be estimated by using an empirical method such as soil survey mapping, soil stature, or particle size distribution. However, a variety of different laboratory and field test methods it just make easy to measure the properties directly. The soil types and the purpose of the test, accuracy is required, and the specimen influence the selected test method.
Okay, there are 14 items that are needed for apparatus of permeability of soil. Okay, number one is we need a permeameter mold, which is internal diameter is 100 meter, effective height is 127.3 millimeter, capacity with 1000 milliliter. Number 2 is detachable collar, 100 meter and 60 meter per height. Number 3 is dummy plate, 108 millimeter diameter, 12 millimeter per thick. Number 4 is drainage base, which is having porous disc. Number 5 is drainage cap having porous disc with spring attached to the top. And number 6 is compaction equipment, such as practice raimer or aesthetic compaction equipment as specified in IS 2720 in year of 1965. Number 7 is constant heat water supply reservoir. Number 8 is a vacuum pump. Number 9 is constant heat collecting chamber. Number 10 is stopwatch. Number 11 is thermometer. Number 12 is large funnel. Number 13 is weighing balance accuracy of 0.1 gram. And number 14, lastly, is a filter.
Okay, for the procedure, the first thing is place soil in thermometer but ensure the porous stone in the bottom. Weigh the soil in the source container. Make sure that scale is there, then take the measurement and record. Place the soil in the thermometer as required, then place the soil in the parameter that will weigh. Record the weight and difference between the two weight of soil. Then place the parameter in order to determine how much soil are needed. Use an IR caliper. According to the ASTM regulation, amount of soil needed from inlet point to top of the sample is 2 times inner diameter of parameter, so 5 inches from center point up to the top of our sample are needed. In order to place the specimen within the parameter, hold the ruler, then place the sign with the funnel. Stop and shake the thermometer a bit to make sure the level and measuring correctly. Have 5-inch mark from the center of the inlet to the top of soil sample. Place a second wire mesh on top of the soil sample again to keep any soil from escaping during uplift. Place some of stone aggregates. Water can flow freely through this. Simply weighing down the soil so we won't have any uplift effect. Next, hook the sample into the water. Set up the water source connected to a faucet. The faucet runs into the reservoir. Need to unclamp hose so that water can flow into system. Slow down a little bit with the water and waiting for equilibrium to be matched, and the outlet is now going into our catcher. To determine the equilibrium reach, observe the water level in the manometer. Next step, measure the difference in total heat. Measure from difference between top of the water level in the thermometer and water level in manometer. The simple ruler can be used to determine the distance. Determine and record the differences total heat to measure how long it takes to fill one graduated cylinder of 250 mm with the water sowing a stopwatch and cylinder. The water reached 250 ml. Record time and repeat the sequence 3 times. Average will be taken to use in calculation. Next step is measure the water timing. To measure the temperature of the water in the cylinder and record a temperature correction with the calculation. Complete the measurement 4 times. Accumulate enough data to perform calculation. Thank you.